Auzubillahiminash-shaytanir-rajim. Bismillahir-rahmanir-rahim. Assalamu alaikum, dear students. Dear students, today our topic is refraction of light through a glass slab. Dear students, suppose this PQ or S is a rectangular glass slab. A ray of light traveling in air along AB. It falls on the PQ side of the glass slab at point B. AB is the incident ray. It falls on the PQ surface of the glass slab at point B, and it makes an angle with this normal, which is known as angle of incidence and is denoted by I. Dear students, at point B it refracts. After refraction into the glass slab, the ray of light bends towards the normal. It bends towards the normal and it goes along the direction BC. It goes along the direction BC and it makes an angle with this normal, which is known as angle of refraction. Here it is denoted by R1. Dear students, चूंकि लाइट रियर मीडियम से डेंसर मीडियम की तरफ जाती है तो ये नॉर्मल की तरफ बेंड हो जाती है. यहाँ ये नॉर्मल की तरफ बेंड हो जाती है. At this point C, on the boundary ORS of the glass slab, the ray of light again suffers refraction. It again refracts and it emerges out from the glass slab into air. It emerges out from the glass slab into air along CD, along the direction CD. Dear students, यहाँ लाइट डेंसर मीडियम से रियरड मीडियम की तरफ जाती है. So it bends away from the normal. Here it bends away from the normal. For this second refraction at point C, BC serves as incident ray. This BC serves as incident ray. Angle N2 CB is angle of incidence here, which is denoted by R2, and angle N2 CD is angle of emergence, which is denoted by E. This is called angle of emergence, which is denoted by E, which is the angle of refraction in air also. This angle E is the angle of refraction in air also. Dear students, in this way we see that refraction of light takes place twice here. In the first refraction, from rarer to denser medium, angle R1, that is angle of refraction, is smaller than the angle of incidence. And in the second refraction, from denser to rarer medium, angle E is bigger than the angle R2. Angle of emergence is bigger than the angle of incidence here. Dear students, from this figure, it is clear that angle R1 is equal to angle R2. This angle R1 is equal to angle R2 because these two angles are alternate angles. These are alternate angles. And this angle E is equal to angle I. Angle of emergence is equal to angle of incidence. This shows that the incident ray and the emergent ray are parallel to each other. Dear students, this is the actual path of the incident ray. अगर ये ग्लास स्लैब यहाँ नहीं होता है तो ये इंसिडेंट रे का एक्चुअल पाथ है. ड्यू टू दिस ग्लास स्लैब द लाइट refracts and it goes along the direction CD. It emerges here and goes along the direction CD. This incident ray and this emergent ray are parallel to each other. This shows that though the emergent ray is parallel to the incident ray, this emergent ray is parallel to the incident ray, but the emergent ray is displaced. This emergent ray is displaced sideways. This is called the lateral displacement. This is called the lateral displacement. Dear students, now what is lateral displacement? When a light ray passes through a glass slab, then the emergent ray parallel to the incident ray produces forwards produces forwards but laterally displaced from it or parallelly shifted from it. It is called the lateral displacement. So the distance between the incident ray and the emergent ray is called lateral displacement. This distance between the incident ray and the emergent ray is called lateral displacement. Dear students, factors of lateral displacement. Number one, it depends on angle of incidence. It depends on angle of incidence. जितना ज़्यादा एंगल ऑफ इंसिडेंस हो इतना ज़्यादा लेटरल डिस्प्लेसमेंट होता है. नंबर टू, इट डिपेंड्स ऑन द रिफ्रैक्टिव इंडेक्स ऑफ गिलास. गिलास की रिफ्रैक्टिव इंडेक्स जितना ज़्यादा हो लाइट इतनी ज़्यादा बेंड होगी. जितनी ज़्यादा बेंड होगी इतना ज़्यादा शिफ्ट होगी. यानी जितनी ज़्यादा रिफ्रैक्टिव इंडेक्स होता है इतना ज़्यादा लेटरल डिस्प्लेसमेंट होता है. इट ऑल्सो डिपेंड्स ऑन द थिकनेस ऑफ द गिलास स्लैब. It also depends on the thickness of the glass slab. Dear students, जितनी ज़्यादा गिलास स्लैब की थिकनेस होगी जितनी ज़्यादा गिलास स्लैब की थिकनेस होगी इतना ज़्यादा लेटरल डिस्प्लेसमेंट होता है. So it depends on the thickness of the glass slab. More is the thickness of the glass slab, more is the lateral displacement. Dear student, this is about the refraction of glass slab, reflection of light through a glass slab. Thank you.